Today I recorded the lesson on an introduction to probability. And in this lesson we're going to talk about what probability is, we're going to talk about what the difference between experimental and theoretical probability is, and we're also going to talk about geometric probability. So there's three things that we're going to cover in this lesson today. So let's go ahead and first get started with the definition of what probability is. So this is the definition of what probability is. Go ahead and copy this down in your notes, make sure that you have it, and in a little bit we're going to go ahead and talk about it. So go ahead and pause the video and make sure that you have this written down. Probability is a way to describe the likelihood of an event occurring. And we're always talking about a number here, and this number is always between 0 and 1. And a good way to think about this number is that if the probability is 1, the event is always going to happen every time you try. And if the probability is 0, the event is never going to happen every time you try. And the closer we get to 1, the more likely it is to happen, and the closer we get to 0, the more unlikely it is to happen. So, what I want to take a look at now is how we actually find this number, how we actually find the probability of an event. And how we do that is we use this equation here. So the probability of an event, and we write that as P, capital P, and then in parentheses the events on the inside is equal to the number of favorable outcomes over the number of possible outcomes. So go ahead and get this in your notes. Now is a good time to pause the video and make sure that you have this written down. So what we've been learning up until this point has been all how to calculate the number of possible outcomes. We've been learning how to do combinations, which order doesn't matter, but you're picking things, and it doesn't matter the order in which you pick, but it just matters what you pick. And we've also talked about permutations, which in permutations you're still picking things, but in this case order does matter. And also we've talked about the fundamental counting principle. And all these things are used to figure out what the number of possible outcomes can be. Let's go ahead and take a look at how to find the probability of an event. So I want to first take a look at how to find the probability of getting heads in a coin toss. And we write that capital P, and the event that we want to have happen is flipping the coin and getting heads. So we need to figure out two things. We need to figure out the number of favorable outcomes, and we need to figure out the number of possible outcomes. So first of all, in a coin toss, there's two outcomes that we can get. We can either get heads or we can get tails. So on the bottom of our fraction, we're going to have 2. And the number of favorable outcomes is going to be 1 because there's only one way to flip heads. So we get this fraction, which is going to be 1/2. And that's equal to 0.5. And you can also convert that to a percentage, which is 50%. And if you guys have ever heard the term there's a 50-50 chance, that means that it's equally likely to land on heads as it is on tails. So I want to find the probability that I'm going to roll a 6. And we can write that as P and then parentheses. On the inside of those parentheses we'll put a 6, and that's saying what is the probability of 6. So this probability is going to be equal to, on the top it's going to be our number of favorable outcomes. In this case it's going to be the number of ways to roll a 6, because getting a 6 is a favorable outcome. And on the bottom is going to be the number of possible outcomes. And in this case it's the number of possible rolls that we can get. So on a dice there are 6 sides, and there are the numbers 1 through 6. And when you roll a die, you can get the numbers 1, 2, 3, 4, 5, or 6. So the number of possible rolls is going to be 6. So we're going to have a 6 in our denominator, and the number of ways to roll a 6 is going to be 1 because one side of the dice has a 6 on it. So our fraction is going to be 1/6. And that's equal to 0.167. So that's our probability. 0.167. If I want to find the probability of rolling a number greater than 4, we can write that as capital P and then in parentheses, n greater than 4. This is saying we want to find a number n that is greater than 4, and that's going to be equal to the number of ways to roll a 5 or a 6, because those are two numbers that are greater than 4 on a die, and we're going to put that over the number of possible rolls. So just like before, the number of possible rolls in this case, we're only rolling one die, and there's 6 sides on that die. So in our denominator, we're going to have a 6, because that's the number of possible rolls. But our numerator is going to be different this time, because instead of only rolling a 6, we can also roll a 5. So at this time, there's 2 different favorable outcomes that we can get. So in our numerator, we're going to have a 2. In our denominator, we're going to have a 6. So we get 2 over 6, which is equal to 0.333. So the probability of rolling a number that is greater than 4 is going to be equal to 0.333. In this example, I want to find the probability that when I roll 2 dice, the dice add up to equal 7. And to help better understand this example, I feel like it's good to list out all the different possibilities. So let's say we roll that first dice. We can get the numbers 1 through 6 on that first die. So let's just say the first die rolls a 1. What are the other possibilities for when I roll that second die? When I roll that second die, I can get a 1, a 2, a 3, and that goes all the way up to 6. So the first die we can roll a 1, and the second die we can roll all the way through 6. So what that's going to look like is this. We have that first die, the die on the left, with all 1s, and then the die on the right has the numbers 1 through 6. Those are all the possibilities where that first die rolls 1. Now let's think about, what if the first die rolls a 2? What are those possibilities? And we can do the same thing that we did in this chart here. We can go ahead and list all 2s, and then the second die we could roll a 1, a 2, all the way up to 6. And then we can keep going with this process to find the rest. We can do it with 3, 4, 5, and 6. So these are all the possible outcomes for when we roll 2 dice. So now I need to figure out how many of these outcomes produce 2 dice that add up to 7. So if we take a look at the bottom left, we know that 1 and 6 make 7. I know that 2 and 5 make 7. 3 and 4. 4 and 3. 5 and 2. And 6 and 1. So we have 6 outcomes that make 2 dice that add up to 7. And we have a total of 36 outcomes. So our fraction for the probability is going to be 6 over 36, which is equal to 0.167. So let's go ahead and take a look at this example, and I want to find the probability of picking an ace from a standard deck of cards. And we can go ahead and write that as P, capital P, which stands for probability, and then we'll put ace on the inside because we're going to find the probability of picking an ace, and that's going to be equal to the number of aces divided by the number of cards. And so what we need to figure out is how many aces we have in this deck. And if you take a look below here, we have all the cards listed out, and I have exactly 4 aces. So I'm going to put 4 in the numerator, and then the number of cards that we have, and it says above, is 52. So 52 is going to be my denominator of my probability fraction. So I get 4 over 52 as the probability of picking an ace, and that's going to be equal to 0.0769. So the probability of picking an ace is equal to 0.0769. So now I want to find the probability of picking an odd card. So what this fraction is going to look like for the probability is the number of odd cards that we can pick, the favorable outcome on top, and the number of outcomes that we can get on bottom, which is the number of cards. So we need to figure out how many odd cards we have and how many cards we have in total to figure out that probability. So as far as odd cards go, we have 4 threes, we have 4 fives, we have 4 sevens, and we have 4 nines. So in total we have 16 odd cards. And the total number of cards that we have, because this is a standard deck, is 52. So our fraction is going to be 16 over 52. And the probability that we get is 0.308. So the probability of picking an odd card from a standard deck of cards is 0.308. Let's take a look at this next example that has probabilities that involve either permutations or combinations. So, in this example, you create an iTunes playlist with 8 songs. You set the playlist to shuffle, and you want to find the probability that the 8 songs are played in the same order that they are in the playlist. So the shuffle is going to go through the first song first, the second song second, all the way to the 8th song. And we want to figure out what the probability that happens is. So first of all, we need to figure out whether we're talking about a permutation or a combination. And just as a little refresher, guys, a permutation order matters. And in a combination, order does not matter. So in this case, we're talking about the probability that the songs are played in the same order. So this should be a key. This is a keyword right here. We have order in the question. So that probably means we're going to be working with a permutation because order matters. And so to figure out this probability, the probability that the songs are played in order, we need to figure out the number of playlists that have that same order, the songs 1 through 8 all in the same order, and we're going to divide that by the number of ways to arrange the songs in a permutation. So we need the number of playlists that have that same order. And because we're looking for all those songs to be ordered 1 through 8, there's only going to be one playlist that has that same order. So in our numerator, we're going to have a 1. And now let's take a look at the denominator. We need to figure out the number of ways to arrange the songs. And so, guys, I want you to notice that we're talking about a permutation here. We need to figure out all the different arrangements we can make with these 8 songs using a permutation because order matters. So what we're going to get is we're going to get 1 in our numerator, and then in our denominator we're going to have to find the permutation of 8 objects when we pick all 8 of them. So to find this permutation, we need to remember that formula. And the formula is equal to the number of objects that we have on top, which is 8, and we're going to take the factorial of that, and then we're going to go ahead in our denominator, we're going to have the number of objects that we have, which is 8, and we're going to subtract that from the number of objects that we're picking in this permutation, which is 8. So in my denominator, I get 0 factorial, which is going to be 1, and I have 8 factorial on the top. So when I do 8 factorial, I get 40,320. And another way to think about this, guys, is we want to pick 8 songs and we want to order them. So how many different ways can I pick that first song? And I can pick that first song in 8 different ways. So we're going to do 8. And then after I pick that first song, when I pick the next song, I'm only going to be able to choose from 7 songs. So we're going to do 8 times 7, and then we have 6 songs to choose from. So we're going to have 8 times 7 times 6, and that keeps going until we get down to 1. And that's what our factorial is representing here. It's representing the number of ways to pick 8 things. And so what we're going to do now is we're going to go ahead and plug in 40,320 into our denominator, and we get, for the probability of playing the songs in order is 1 over 40,320. And as a decimal, we get 0.000025. and that's a very small number. I want you guys to notice that this number is very close to 0, and it's very unlikely to happen. So, the probability that we're going to play all 8 songs in the same order that they are in the playlist is very small. So, let's go through another example that either involves permutations or combinations. So in this example, we have the same playlist, but within this playlist we have 4 of my favorite songs. And I want to find the probability that I play 2 of those favorite songs first. So let's go ahead and think back all the way to when we were talking about probability, and I need to figure out what the number of favorable outcomes is going to be. So a favorable outcome in this case is going to be playing 2 of my favorite songs first. And then I need to figure out what the total number of outcomes is going to be. And a way to think about this, guys, is the number of ways to choose my 2 favorite songs. And we're going to divide that by the number of ways to choose the first 2 songs that are played in the playlist. So what we need to figure out right now is how to find the number of ways to choose 2 of my favorite songs, and the number of ways to choose 2 songs from the playlist. And if you guys aren't too sure about this, that's okay, but you should notice that these probabilities either involve a permutation or a combination. And in this case, let's take a look. Permutations, order matters, which means that the way that the songs are ordered is going to matter. Am I worried about the way that the songs are ordered in this case? Let's take a look. So it says, what is the probability that 2 of my favorite songs are played first? So we do want them played first, but it doesn't matter which songs are played first. So in this case, order does not matter. So we're going to go ahead and do a combination up here and a combination down here. And so to figure out what those combinations are going to be, we have 4 of my favorite songs, so we're picking from 4, or sorry, we have 4 things that we're going to pick from, and we're picking 2. So that's a number of ways to choose 2 of my favorite songs to play. And then on the bottom here, we need to figure out the number of ways that we can choose 2 songs from a playlist. And we have 8 songs in our playlist, so that's going to be our number of objects that we can pick from. And then we're picking 2 things from that list. So let's go ahead and we're going to calculate this first one, the combination, the 4 choose 2. And guys, we say 4 choose 2. Anytime you see choose in here, that's usually a good sign that we're going to use combination. So in this case, our equation for the combination here of 4 choose 2 is equal to 4 factorial, our n, the number of things we could pick, over our number of things we can pick minus 2, and then we're going to take the factorial of that, and we're going to multiply that by the number of things that we pick, and the factorial of that. So when I do 4 minus 2, I get 2 on the bottom, factorial. And then 4 factorial is going to be equal to 24. That's 4 times 3 times 2 times 1. And now I can go ahead and do 2 factorial times 2 factorial, and that's going to be 4 on the bottom here. So we do 4 divided by 24, and we get 6. And now what I want to do is I want to plug this 6 in for the 4 choose 2. So we'll go ahead and plug it in. So what we need to do next is we need to figure out what 8 choose 2 is. And I'm not going to run through the steps because I think you guys can do that yourselves. You guys have a lot of practice with that. But what we do get is we get a fraction of 6 over 28 as our probability. And what that is as a decimal is 0.214. So the probability that I'm going to play 2 of my favorite songs first is 0.214%. Uses experimental probability. So let's go ahead and take a look at that. So experimental probability is the probability that an event occurs during an experiment. So I created my own experiment with all the free time that I have, and I rolled the dice 180 times. if you look at the top here, we have the roll numbers. So I rolled a 1 8 times. I rolled a 2 18 times. I rolled a 3 34 times. I rolled a 4 22 times. I rolled a 5 46 times. And I rolled a 6 52 times. And I want to figure out what the experimental probability was for rolling a 6. So to figure out that probability of rolling a 6, I need to figure out two things. I need to figure out how many times I rolled a 6 in the experiment, and I need to figure out how many times I rolled the dice altogether. So let's take a look. So to figure out how many times I rolled a 6, I'm going to use the chart, and I rolled a 6 52 times. And to figure out the number of times that I rolled the dice altogether, you could either add up all of these, but I also give it to you guys right up here. I rolled the dice 180 times. So my fraction is going to be 52 over 180. And so my experimental probability for rolling a 6 is going to be 0.2889. And the theoretical probability of rolling a 6, we calculated that earlier, was 0.167. So if you guys notice, the probability that I got for rolling a 6 was much higher than the actual probability it should have been. But this can happen in experiments, because experiments aren't perfect. So what I want to do now is I want to figure out the probability from this experiment that I got a number bigger than 4. So I need to figure out how many times I rolled a 5 and a 6. And if we take a look, I rolled a 5 46 times, and I rolled a 6 52 times. And then all together, I rolled the dice 180 times. So my fraction is going to be 46 plus 52, the number of 5s that I got, plus the number of 6s that I rolled, over the total number of rolls I did. So this tells me how many times I got either a 5 or a 6, and this tells me how many times I rolled altogether. And the experimental probability of that is going to be equal to 89 over 180, which is 0.54. And the theoretical, which we calculated earlier in the lesson, was 0.33. So the experimental probability that I roll a number bigger than 4 is much higher than the theoretical probability. But that's okay because this is an experiment, and I'm interested to see what you guys get. So the last thing we're going to talk about is the geometric probability. And it's the probability that can be related to either length, area, or volume. And a way to think about this as far as a probability goes is we're talking about the amount of favorable region, so whatever we're looking for on top, and we're going to divide that by the total region on bottom. And whatever we have on top, whether it's a length, an area, or a volume, we should also have a length, an area, or a volume on the bottom. So those two should match up. So what I'm going to look for as far as geometric probability goes is I want to find the probability of hitting the third ring of this dartboard. And if you guys take a look here, we got our first ring is the center, it's red. The second ring is right here and it's green. And our third ring is going to be this big one out here. This whole thing. So what it's going to look like, if I were to go ahead and highlight it, is this. And guys, make sure that you have these dimensions written down for the square board right here. We have 60 as our width and 60 centimeters as our length. So what we're going to try to do right now is figure out the area of this circle. So what we're going to try to find is the probability of hitting the third ring. And if you notice, this dartboard has a length of 60 centimeters and a width of 60 centimeters. Make sure you guys have that down because we will be needing that for our total area, because our total area is going to be this big square out here for our board. And then we want to find the probability of hitting the third ring. So I need to figure out the probability of hitting this area right here. This is my third ring. I'm going to go ahead and highlight it right now. So this is our third ring right here. And I want you guys to notice something. Do you notice how our third ring, we have a circle on the outside and then a circle on the inside? If we hit anywhere in here, we're hitting either the first or the second ring. So what we're interested in is the area of this ring right here.
and we're going to divide that by the total area, which is the area of this square right here. So what I want to find first is the total area. And to do that, I'm going to need to figure out this area right here of our board. And if you guys notice, our length is 60 centimeters and our width is 60 centimeters. So that means that we have a square. And to find that area, what we're going to do is we're going to multiply the length times the width. And this is going to be our total area. So our length was 60 and our width was 60. So we're going to multiply those two together to get a total area of 3,600. So we've found the total area, and that's going to be our denominator of our probability. What we need to find next is the numerator. And how we're going to do that is we need to take a look back at our dartboard, and we have two measurements here. For that inner circle, right here, we have this has a radius of 3 centimeters. And then for our length right here, from the green edge to the green edge, we have a length of 12 centimeters. So what we want to find is we want to find this green area. And to find this green area, what I'm going to have to do is I'm going to have to find the area of this bigger circle. So once I find this area, I almost have the green area. The only thing I need to do is I need to subtract the area of the smaller circle. So let's first start by finding the area of the smaller circle. So the area of a circle is going to be equal to pi times r squared. And for my small circle, what I'm going to get is that's equal to pi times the radius of the small circle, which is 3, and we're going to square that. And when I square 3, I get 9, so I'm going to get 9 pi for the area of my small circle. And then I want to find the area of my large circle. But before I can do that, I need to figure out what the radius of the larger circle is. So let's go ahead and go back to that. The radius is going to start from the center and go out. So it's going to be the 12 centimeters here, and then the 3 centimeters here. So to get that radius, we're going to have to add the two. 12 plus 3 makes 15. And we get the area of the big circle is equal to pi times 15 squared. And then 15 squared becomes 225 pi. So now to find the area of the region that we're looking for, we're going to take 225 pi and we're going to subtract 9 pi from that. And so that's going to be the area of the third ring. That's going to be equal to 225 pi minus 9 pi. And when I subtract those two, what I get is 216 pi, which when we multiply is going to be 710. So now that we've found the area that we're looking for, the area of that third ring, which is 710, what I'm going to do is I'm going to plug that into my equation. This is the region that we're looking for, or interested in, so that goes in my numerator, and in my denominator I put the total area, which was the area of that square, which was 3,600. So the probability of hitting the third ring is going to be 710 over 3,600. And when I divide those two, I get 0.197. So the probability is right around 19.7% of hitting. So that's all that I have for you guys today. I will see you when I get back.